Hello scholars, you're welcome back to the day 5 of our 2026 JAM and Waec Chemistry Masterclass. So in this class, we are going to look at the continuation of the Iupac Nomenclature of organic compound. And in previous class, we looked at the basics or the introduction to this particular topic. Again, just to introduce myself, I am Michael Warren, the lead tutor at Warren Science Academy. So if you are new here, you can do it to click on the subscription button somewhere beneath this video lesson so that you always get notified whenever I release a new video. And during the course of or in the course of this lesson, if you have any question, do it to leave them in the comment section beneath these video lessons, as all questions will be attended to in the course of this class. So in this class, we are going to look at the Iupac Nomenclature of organic chemistry of organic compound part 2. So in the first class, we looked at the basics. And in that class, we talked about the definition of organic chemistry. We looked at the uniqueness of carbon atom. And then we went on to look at what we call the homologous series and then functional group. So just to do a recap, we said that organic chemistry is the study of carbon and its compound with some certain exceptions. And those exceptions include the triazocarbonate of metal. We talked about the oxides of carbon, the metallic cyanide, and then we'll talk about the oxide of carbon, the metallic cyanide, the triazocarbonate. So in organic chemistry, we don't study those compounds. So we don't study the oxide of carbon, we don't study the metallic cyanide, and we don't study the triazocarbonate of metal. And then we went on to look at what we call the uniqueness of carbon, or what makes carbon unique. Now, the uniqueness of carbon includes the fact that, number one, carbon has that ability to catenate. I would say catenation is the joining of like atoms together. And thereafter, we also said that carbon can form what we call multiple bonds, like double bond and then triple bond. And also, carbon has that unique ability to undergo what we call hybridization. So this and some other uniqueness are what we looked at about the carbon atom. And thereafter, we went on to look at what we call the homologous series. And so we said the homologous series are families of organic compounds in which each successive member differ by what we call a CH2 group, and not just a CH2 group, or a 14-gram mass. So each successive member, the difference between each of them is a CH2 group and a 14-gram mass. And also we said that this homologous series is a family and they share a general formula which you can use to derive all the members in that family. And also we also looked at what we call the number of carbon atoms. We look at the prefix for this number of carbon atoms. For example, we said one carbon atom is clearly represented with a met, 2 is it, 3 is prop, so on and so forth, down to the final carbon atom we can always arrive at. And then we also look at what we call functional group. We say functional group are just atoms. They can be group of atoms, or they can be bonds that are unique to a particular homologous series. For example, when we get to see a family that have single bond or single bond, we clearly refer to it as an alkane. When we see a family that have double bond, we clearly refer to it as an alkene. When we see that has triple bond, we clearly refer to it as an alkyne. So these and so many other stuff we look at in our previous video lesson. So if you missed that video lesson, I will do it and I will advise you to go back to that video lesson at the end of this class so that you get to learn and understand the basis of organic chemistry. Because in this class, we are going to focus on how to name organic compounds. And then we're also going to focus on how to draw organic compounds. So this is what this video lesson is going to be centered on. So do it to take your writing materials, because at certain point in this class, I will advise you to sketch or draw or even name before I attempt the question. So do it to get writing materials so that you can follow through and also you can be the best version of yourself at the end of this class. I want to see you as a chemistry guru. So let's get started. So we are going to start with the naming aspect. But while we are naming, we are also going to draw alongside, because it's one thing to know how to name a compound, it's another thing to know how to sketch when giving the name. So you must be able to do both of them. You should be able to name and also to sketch the structure of that particular compound that you have been given. So we'll start with family by family. We'll take them family by family before we now look at some questions from the jam pass question. In our previous class, I gave us a list of homologous series. We talked about alkane, we talked about alkene, we talked about alkyne, down to the nitride. So we are going to talk about them one by one because each of them have a unique way of naming them. But before we do that, I'm going to give you a general overview of how to name organic compounds. So we are going to look at steps in naming organic compounds. Steps in naming organic compound. So the first step is that you should identify the longest continuous carbon chain. Identify the longest continuous carbon chain bearing the functional group and then this longest continuous carbon chain, we are going to take it as what we call the parent carbon atom or the parent carbon chain. So it's going to form what we call the parent name. Then the second thing we are going to do, we are going to identify what we call substituent. Identify the substituent. Then the third thing we are going to do, we are going to number the carbon atom. We are going to number the carbon atom such that the substituent and the functional group, so let's say the functional group first of all, that's the main thing, the functional group, and the substituent take the smallest possible number. Emphasis on this word, smallest possible number. They take the smallest possible number. So basically, these are the three things we expect to do, but there are some additional stuff you ought to know. One of them, we talk about prefix for carbon atom. For one carbon atom, the prefix is a met. For a two carbon atom, it's et, ETH. For three, it is prop. For four, it is but. For five, it is pent. For six, it is hex. For seven, it is hept. 8, oct, 9, non, and 10, dec. We can go beyond 10, but at least these 10 are very basic for your exam, especially those people that are writing the UTME and the SSCE. So these are the first three important steps. But then some additional step we have is just that. So we use di for two substituents. So I'll just write two sub, that's two substituents. We use tri for three substituents and tetra for 4 substituents. So now this is different from the met, et, but, prop, but those are for the number of carbon atom. This word di is 2 for substituent, tri is 3 for substituent, tetra is 4 for substituent. From here, you can then continue with our pent, our hex, our hept, oct, non, and dec for substituent. But basically, for your first 3, 2, 3, 4, it is 2 di for 2, 3, tri for 3, and then tetra for 4. So now these are the big steps we need in naming any organic compound. It's just a general way, because when we look at different families, there are not some peculiarities, but it's just a general way we can name any organic compound. So that's why we are going to look at each family one after the other, so that you know the peculiarity. Because the way you are going to name an alkanoid is different from the way you are going to name an alkane. It's also different from the way you are going to name what we call an alkoxyalkane. So those peculiarities are what we are going to look at when we touch each of these homologous series. Remember, these homologous series are families of organic compounds. We are going to look at them family by family. So the way one family will behave is different from the way another family will behave. So those peculiarities are what we are going to look at. But these steps are general steps for naming any organic compound. So now the first step, let's talk about the first step, but I'll do so with an example. So I'm going to draw a compound and then we'll work with it. So let's take a compound and then we are going to work with it. Okay. So let's draw something. So So now this is a compound we have right here on the board. So now when we look at this compound, this is a good example of an organic compound. Now we want to name it. Now how do we name it? That's where the issue comes from. Now the first step says you should identify the longest. Now emphasis on this word, the longest continuous carbon chain. Longest continuous carbon chain. Now your carbon chain must not always be straight. That's one place where students miss it. Your carbon chain can be bent. Like your carbon chain can be like this. Your carbon chain can be something like this. So your carbon chain is not always, we are not saying a straight horizontal chain. It's the longest continuous carbon chain. So your carbon chain does not necessarily have to be this straight chain. It can even be bent. It can be triangular. So emphasis on the word longest continuous carbon chain. So when we look at this is going to be our longest continuous carbon chain. This is one, a chain. You see them carbon to carbon to carbon to carbon. That's the chain. So this carbon to this carbon to this carbon to this carbon to this carbon. So if you count, you are going to find out that we have 1, 2, 3, 4, 5. So this is kind of the longest. If you also go like this, 1, if you 2, 3, 4, 5, that's also 5. If you come like this, 1, 2, 3, that's short. 1, 2, 3, this is short. 1, 2, 3, 4, 5. So in all, if you keep counting, the highest you can get is 5. So I'm going to take this as the longest, or let's use a different. We're going to take this as the longest continuous carbon chain. So this is going to be the longest continuous carbon chain. So when you do that longest continuous carbon chain, you are going to name it. First again, your longest chain must contain your functional group. We are going to see examples that contain other functional groups. For example, in this case, we all have single bond. So, and a form that contains single bond, we best refer to it as an alkane. So now, coming back, that longest continuous carbon chain, we are going to name it as what we call, we are going to give it the parent name. So in this longest chain, we are now going to ask ourselves, how many carbons do we have here? So we have 1, 2, 3, 4, 5. We have 5 carbon atoms. And the prefix for a 5 carbon atom is a pent. So take note. So the parent name will be a pent. But that's not all. Now, in this longest chain, all of them, they are all single bond. And a family in which all are single bond, we call them alkane. So we refer to them as alkane, A-L-K-A-N-E. So we are going to add this A-N-E to the name. So this is going to be a pentane. So the parent name for this longest chain is a pentane. So we are done with that. So now, moving on from that part, so we know that the parent name for this is pentane. So that's the longest continuous carbon chain, and we are done with that. The second step says identify the substituent. So the question we ask ourselves, what is substituent? Now, anything that takes the place of hydrogen is a substituent. Because generally, or basically, when we talk about organic chemistry, we are talking about two major elements, which are carbon and hydrogen. So it's carbon and hydrogen. So we are talking about these two major guys. That's why they form what we call hydrocarbon. Like when you see the name hydrogen, carbon. So when we talk about organic chemistry, two major elements that come to our mind are carbon and hydrogen. But that does not mean that we have other elements too. But the two major elements are carbon and hydrogen. We can have other elements like oxygen, nitrogen, sulfur, chlorine, so on and so forth. So now anything that takes the place of hydrogen is a substituent. Anything, be it an atom, be it a group of atoms, it's a substituent. So now if you look at this particular part, so if you look at this particular part, there should be an hydrogen here. But right now, CH3 has taken the place of hydrogen. Similarly, here, CH3 has taken the place of hydrogen. And also at this point, CH3 has taken the place of hydrogen. So a chlorine has taken the place of hydrogen. So these guys, we refer to them as substituents. So you must identify them and possibly name them. So CH3 is a methyl. If you remember, we talked about alkyl. And what are alkyl? We said alkyl are alkanes that have lost an hydrogen atom. So when an alkane loses an hydrogen, it becomes alkyl. So CH4 is methane. When CH4 loses one hydrogen, remove one hydrogen, becomes CH3. So this compound is methyl. So hence for this one is a methyl. So we are going to just name them. So this is methyl. This one beneath is methyl. And then this is a chlorine. But we are not going to call it chlorine later. Please let me check the screen if the camera covers everything. Okay, so it is well covered. So let's proceed. So we have methyl as a substituent, chlorine as a substituent, methyl as a substituent. So we are done with the second part of naming of this compound. Now the third thing says number the carbon atom such that the functional group and the substituent take the smallest possible number. Now look at something. This rule is not a rigid rule, like you must always number from the front. We are going to do something called numbering. The rule is not so rigid that you must always number from the front. You can number from the front or you can number from the back. That's just it. So I can start numbering from here or I can start numbering from here. So when I have to number from here, so look at something. Let's number. We are going to number forward and backward. So let's go. So let's take it as 1, 2, 3, 4, and then 5. So I've numbered from front to back. Now I can also do so. I can also number from back to front. So this is going to be 1, 2, 3, 4, and then 5. So I've numbered either ways, forward or backward. Now you can number in any way, but the crucial thing is that your numbering must give your functional group. In this case, we don't really have a definite functional group except from a single bond. And you must also give your substituent. First of all, your functional group, then your substituent. You must give them the smallest. Now, this is the crucial statement here. You must give them the smallest possible number. Now, we don't really have a definite functional group here, so let's move to the substituent. Now, if you look at a substituent, chlorine, methyl rather than chlorine. With this forward numbering, it falls on carbon 2 and carbon 3 with this forward numbering. But from the backward, it falls on 3 and 4. So 2 and 3 and 3 and 4, which is smaller? 2, 3 definitely. 2, 3 is smaller than 3, 4. So we are going to use the forward numbering and not the backward. Why? Because it gives this our substituent the smallest number. Obviously, 2 is smaller than 4. So definitely we are going to use 2, 3. So I'm going to take off this backward numbering. So there are some cases where your backward numbering gives your substituent or your function the smallest number. Fine, you are going to use the backward numbering. So the crucial thing is that your functional group and substituent must take the smallest possible number. So in this case, we are going to use the forward numbering. So when we are done with this, we can therefore name our compound seamlessly. So how do we name? Good, I forgot to add that. We are going to name, so let me just add that as the fifth one. So the fifth rule, I'm going to put it here, or let me place it somewhere around that area. So your fifth step, very, very important, is that you should name number 5. You are going to name the substituent alphabetically. Name the substituent alphabetically, very important. Alphabetically. Now what does this thing mean? It means your substituent, you are going to name them just as way you write your alphabet, A before B, B before C, and C before D. Now, how are we going to name? This is methyl. Methyl starts with M, chlorine starts with C. So obviously C comes. You must add the position. Very important. You must tell us the position. So now how do we write it? So chlorine is a carbon 3. So it's going to be a 3. Now take note, we are writing the final name. So it's going to be a 3 chloro. So like I told you, I'm not going to call it chlorine anymore. It's going to be a chloro. If you have chlorine, call it a fluoro. So if you have iodine, call it an iodo. That's how it applies. So this is going to be a 3 chloro. So we have 2 other substituents, methyl here, methyl here. Now this methyl is on carbon 2. This methyl is also on carbon 2. So we must indicate their position. I must indicate the position of this one and the position of this one. So I'm going to write as 2, 2. This for the first methyl, second methyl. So 2, 2. If one is here and one is here, I'm going to say 2, 4. If one is here and one is here, I'm going to say 1, 5. You must indicate their position. Now, how many methyl do I have? I have 2 methyl. That's where I talked about using these guys for substituent. Since I have 2 methyl, meaning I have 2 substituents, I'm going to use a dimethyl. So I'm going to write as a dimethyl. Dimethyl. So this is how you write your substituent. You must write their position, and if there are more than one, you must indicate it. 2 for di for 2, tri for 3, tetra for 4. When we are done naming the substituent, you can then add the parent name. Remember, I said the parent name is a pentane, so this is called pentane. So this compound is a 3 chloro 2,2 dimethyl pentane. So this is how easy it is to name this compound. So I hope you understand this. So this is just a general step for naming of organic compounds. Like I said, there are peculiarities as we move from one family or one homologous switch to another family. So we're going to look at them one after the other. So also, like I told you, it's very important because we are doing two things in this class. We are looking at how to name compound and also how to draw structures. So that's what we're going to do. So I'm going to draw the structure again for this particular name so that we will learn both of them side by side. So we are going to look at them side by side. So let's go on. So I'm going to draw the structure for this particular compound. So please, here are the steps again. I'll just go by it. The first is that we identify the longest continuous carbon chain that bears the functional group, very important, and that longest carbon chain will give us what we call the parent name. The second thing is that you should identify the substituents. Like we said, substituents are things that are not hydrogen or they take the place of hydrogen. The third is that you must number your carbon atoms such that your functional group and then your substituent should take the smallest possible number. Now, it is for this reason that you can number from front to back or from back to front. There is no rigid rule about this thing. So it's, at some point, your forward numbering is what you are going to use. At some point, you are going to use your backward numbering. The key thing is that your functional group and your substituent, they take the smallest possible number. That's just basic. Now, the fourth thing is that for substituents, when they exist more than once, you use di for 2 substituents, you use tri for 3 substituents, tetra for 4 substituents, then penta and the rest for more than 4 substituents. And then the last thing is that in naming, you must name your substituent alphabetically. So it means you are going to follow your system of the alphabet. So A should come before B and B should come before C, irrespective of whether it's on carbon 3 or carbon 2. That does not matter. That's why in this case, there's 3 there before 2. We are naming alphabetically. C before methyl, chlorine before methyl. Please, not chlorine before the D. It's chlorine before methyl. So now we are going to draw this compound so that you get to understand how to draw and how to name. So let's go. So if you have any compound, either you want us to draw or name, please leave them in the comment section. We are going to look at them in the course of this video lesson. So now that compound we had there was 3, so we just want to draw so that we get it. So that's a 3-chloro. We had a 2,2 dimethyl pentane. So how do you draw? Because in your exam, they will give you a name and ask which of the following structure correctly represent the name you have been given. So this could be, and then they could give you 4 options with 4 different structures. And then you have to pick. In some written exams like the SSCE, you could be meant to draw. So you should know how to name a compound, also how to draw that compound. So now when you have to draw, you must start from the parent. That's why it's a parent. The parents, they must exist before the children. So the substituents are just like the children. So the parents must exist before the children. So we are going to start with the parent. The parent here is a pentane. So now if the pent means 5. So in your own best way, draw a 5 carbon atom. So we are going to draw a 5 carbon atom. That's what this pent here means, pent. So we have done that. Now the N tells you that this guy is from the alkane. And remember, alkanes have all single bonds. So I'm not going to add any other bond to this. So we are going to leave them at their single state. Now, when we are done with that, you will now come back to your substituent. So we are done with the pentane. Pentane tells that a 5 carbon atom with all single bonds, pentane. So we are now going to come to your substituent. So we can now start from here. This is 3-chloro. So some persons we just number. So let's number. So let's say this carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So 3-chloro tells you that there's a chlorine on carbon 3. So go to carbon 3 and then put just 1 chlorine, Cl. So now this, so we'll now come to this part. This one says dimethyl. Dimethyl, di means 2. It tells that we have 2 methyl on carbon 2 and also on carbon 2. So I'm going to draw 2 methyl on carbon 2. So methyl is CH3, CH3. Then that's also, we have exhausted the substance. So when you have done this, fill it with hydrogen because every other space belongs to hydrogen. So you have to fill it with hydrogen, H, 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 and H. Simple. So this is how you draw. So if, let's take another case, let's say we have 2, 4 here, 2 and 4. Now what does this mean? This means we have 2 methyl, but one is on carbon 2, one is on carbon 4. So I'm going to put one here, and then I'm going to put the other one on carbon 4. So we're going to have it here. Then I'll cover here with hydrogen. Now you can put it up, you can put it down. I can put this methyl, I can put it down. There's no rule, there's no rigid rule to wherever the methyl must be located. But take note, that's how you draw compounds. So you always start with the parent name, then move to the substance, and when you are done, fill up the other spots with hydrogen. Now, mind you, something very, very important, very, very important, is that carbon, please take note of this, carbon can only be surrounded by 4 bonds, not more than 4 bonds. I've seen questions like this in exam. Now, when carbon, if you look at carbon, for example, this is a carbon atom now. So let's take a look at this. This carbon has this 1 bond, 1, 2, 3, 4. Simple. 5 more than 4 bonds cannot surround carbon. So that's why when you are drawing, if you see a comma like this, let's say for example you see a comma like this. This is wrong. Why is it wrong? Here you have two bonds, 1, 2, 3, 4, 5. That's totally wrong. Totally wrong, because more than 4 bonds cannot surround carbon. The highest is 4. Remember, when we talk about the uniqueness of carbon, let me take you back to our previous class. One of the uniqueness of carbon is that carbon has a maximum valency of +4. So we said carbon has a minimum valency of +2, minimum of +2, and then a maximum of +4. This valency just tells the number of bonds they can form. It tells that the highest it can form is 4, not more than 4. So if you have a compound where there is more than 5 bonds, know that that structure is totally wrong. So that's why if you count all the bonds, for example, this carbon atom, if you count, find out that we have 1, 2, 3, 4. So 4 bonds will always surround any carbon atom. Simple and pure. So now let's proceed. So like I told you, we are going to look at each family. We are just going to take different compounds from each family just to understand how they are named. So let's go. So we'll start with alkane. Alkane is the first family we are going to start with. So let's start with the alkane. So let's go. We have what's called the alkane. So let's start with the alkane. So remember, I'll just give you some bit of reminder. Now, alkanes, they have single bond. Fine. And then their general molecular formula, which you could be asking in the exam, is that general molecular formula for the alkane is CnH2n+2. Please don't forget this. So we'll just look at some compound, and I'll take them from the jam pass question. So let's go. So we are going to take some questions from the jam pass question, and then we are going to name them. So, but then I'll start with a very simple compound. So let's start with let's take this question. This question is from JAM 1984, question 49. So let's take this question. Now this is the question. So the first question we're going to look at is something like this. We have the CH3, we have this, we have the C, we have an H up here, we have the CH3, we have the CH2, and then we have the CH3. Now this is a compound. Now please, very important in exam. Compounds can either be given, you could be given a compound that is fully stretched out. That's just the open structure. There could be you could be given a compound that is so close. We call it the condensed formula. So this compound is just like packed together. So it is not stretched out. On your own, you can stretch it out. But then with time, you may never really need to stretch it out because you can just name it easily by looking at it. But let's stretch it out so that we easily understand this stuff. So now this CH3 means to this carbon, 3 hydrogens surrounding it. So we are going to write like this. H, H, H. So we have this carbon here. Let's just leave this one. H. Here we have CH3. This is C. H to mean to this carbon, 2 hydrogens surrounding it. So we are going to put one up and then put one down. So that this carbon can bond to the next carbon. So there can be a bond for the next carbon. Then it's CH3 again. H, H, H. So that's it. Remember, this is JAM 1984. So this is UTME 1984 question 49. So you can always make reference to your past question. So now this is the structure. So we just have to stretch it out so that we can easily name it. Now when we stretch it out, we'll get to find out that this guy here is our longest chain without wasting much time. And this chain has 4 carbons. So 4 carbons is rightly referred to as a boot. So that's a boot. And they are single bonds. Single bonds are the alkanes, butane, So now when we have done that, remember, you are going to identify your substituent. So this is the only substituent we have here. This substituent we have here. So we can number from left to right or from right to left. Like I said, there's no hard rule to that. So this 1, this 2, this 3, and then this 4. From the back, we have 1, we have 2, we have 3, and then we have 4. So that's that for that. So from left to right or from right to left. So when we have done that, let's just see how we can name it. Now, remember, you are going to give this substituent because this is a substituent we have a CH3. And remember, this guy is a methyl, so let's just name it. So that's a methyl. So you are going to give it the smallest possible number. Now, if you look at the forward number 1, 2, this guy falls on carbon 2. From the backward 1, 2, 3, it falls on carbon 3. So obviously, we are going to use the forward and not the backward. So let me take it off the backward numbering. So how do we name? Methyl is on carbon 2, and that's the only methyl we have. So it's going to be a 2-methyl, and then add the parent name, butane. So this compound is clearly a 2-methyl butane. It's as simple as that. Let's take another question so I can get this concept clear. So now let's take another compound. So I'm going to take this compound. This is JAM 1979 question 8. Okay, sorry, this is a different family. This is an alkane. So let me take another alkane. So let's take this one. This is from JAM 1981 question 45. So this is how the compound is given. So we are going to name. So we have a CH3. Then we have we have a CH3 like this. We have an CH3 all connected to a CH, all connected to CH2, all connected to a CH3. So this is the compound we are looking at. So that's how a compound is drawn. Now, one very important thing I will always advise you: never be afraid of the structure, no matter how to bend it. Now, some person seeing this might just have this sudden anxiety or this fear. So don't allow the structure to bother you. For me, what I'll do is that I will just draw it again in this straight format. So let's draw it again. But in this case, I'm going to draw it from the back. So let's take from the part we feel is easier to the part we feel is complex. So from the back, we have C attached to 3 hydrogen. So this is going to be a C attached to 3 H. So the next is a carbon with 2 hydrogens. So this is a carbon to H and then H. Then we have this carbon attached to 1 hydrogen first. So look at something. Carbon, there's 1 hydrogen. Now this same carbon is attached to this CH3. So let me put it here. C1, 2, 3, H. So then this last space is where this last compound will come. You can write it in full, but I just prefer to write it as CH3 because clearly that's the substituent. Now, this compound is similar to this compound we just named. The difference is just what my scale student is just the structure. Don't be afraid of the structure. Try and redraw it, probably in a straight format, and then name your compound. So now, this is also, because if you number it, this is going to be a 1, 2, 3, 4. 4 carbon atom, which is a butane, because that's the longest chain. And then these are substituents, methyl. Methyl is of carbon 2. So the name for it is still going to be a 2-methyl butane. Just imagine, JAM repeated this question twice, but in 2 different structures or in 2 different ways, but they are the same thing. So both compounds are clearly a 2-methyl butane. So I hope that's clear. So let me give you a third question, and if you are following the video right now, I will encourage you to quickly name this compound before I name it. So the third question, so let me just take a question that has to do with alkane. So let me take this question. So look at this question. This question we have here. It's CH3. We have a CH2 to a carbon to a CH3 to a CH3 down to a CH3. So this is the third and last question we take on alkane. So I can look at other families. So if you are watching this video right now, I will encourage you to quickly name this compound. I will check the comment section. If you are able to name it, drop your answer in the comment section. Let me know. So quickly name this compound. I'll come back and name this compound. Okay, so I've gotten an answer from the comment section, and the answer says it's a 2,2 dimethyl butane. So let's see if that person is correct. So now let's go. So this is a compound. Like I told you, most times in your exam, you'll be given this compound in a condensed form. So the best you can always do for yourself is to stretch out this compound and then you name it. So this is a CH3, so we are going to name it. So this is going to be CHHH. Then we have a CH2, it will be a CHH. Then we have it attached to a carbon, to a CH3, to a CH3, to a CH3. So let's just stretch this out. So HHH. Sometimes I end up not stretching these substituents. So now when we have done that, remember, identify your longest chain. Longest is clearly this butane. Please, I'm saying this again. Your longest must not always be this straight chain. Probably you'll get to see questions like that. But for now, these are longest continuous carbon chain. And then you're going to identify your substituents. So these are substituents, clearly this and clearly this. And they are both methyl. So the next is for you to number. So when we number from left to right, you're going to have a 1, 2, 3, 4. And from right to left, you're going to have a 1, 2, 3, 4. Now, when we use the 4 numbering, 1, 2, 3, both substituents are carbon 3. But when we use the backward, 1, 2, 3, 4, both substituents are carbon 2. So 2 and 3, which is smaller, is obviously 2. So that means you are going to use the backward numbering. So this is a good case where you are going to use the backward numbering. So like I said, don't always be rigid about numbering. So let me clean this off, clean this off, clean this, and clean this. So you are going to use this. So with this, both substituents are carbon 2. So this is going to be a 2,2 dimethyl because we have 2 of this methyl. Now this is a 4 carbon atom, all single bonds. So it's going to be a 2,2 dimethyl butane. So I hope you got the answer to this question. So to the person who said 2,2 dimethyl butane, you have done well. So this is just all about alkane. So there are a lot of compounds. So one thing I will advise you is that at the end of this class, try to get your past question. Either you're writing SSCE, the UTME, GCE, any related examination where you are going to find naming of organic compound relevant. Try to attempt your past questions and just know how to attempt naming of organic compound. So the second thing we are going to look at is the alkene. So let's move on to the alkene. We just want to look at them generally. Then on a particular day, we can do a video which we are going to answer as much questions as possible. So the next thing we are going to look at is the alkene. So now we are going to look at the alkenes. The alkenes. So something unique about the alkenes is that they have double bond. So you see a double bond, the first thing that should come to your mind is that this is an alkene, provided in the longest continuous carbon chain. In fact, it should be the longest continuous carbon chain. And then the general molecular formula is a CnH2n. So that's the general molecular formula for the alkene. So we are going to look at how to name compound, but we are going to use the UTME past questions to do that. So let's take some questions. So there's a question right here. So let's look at this particular question. So the compound we have here is C2H5. So we have this compound C2H5. Then we have a CH2. Then we have a C. Then we have a double bond O. Sorry, that's a mistake. So let's take that off. So that is a CH2. Then there's a double bond on this particular side. So we have a double bond. And then we have, this is just a C. Then beneath is a CH3. And then we have a CH2. So that's that for that. Again, this compound or the structure here is condensed. Now, something very important is that you should expand it so I can make the naming easier for you, especially if you are new to this stuff. So now, C2H5 meaning there are 2 carbon atoms, and attached to these 2 carbon atoms are 5 hydrogens. So let's start. So we're going to draw the 2 carbon atoms. Please, you must bond this carbon atom together. That's why one of the uniqueness of carbon atoms is what we call catenation, joining of like atoms. It's wrong to say C, then you put an H, you come and put a C. Totally wrong. It's carbon to carbon to carbon to carbon. As I said, the longest continuous carbon chain. So we are going to add a carbon here. So carbon to carbon. And then we have this. So we have this five hydrogen. So this is one, this is second, this is the third, this is the fourth, and then this is the fifth one. Now, attached to them is another carbon atom. Beneath it is a CH3. You can decide to draw it in full, but I'll just decide to leave it like this. Then there's a double bond. Here is a CH2. Let's just put it here. Now, some person might be looking at this compound and wondering, why is this place empty or why is it bored? So it's not empty. Remember, I told you something earlier. 4 bonds will always from one carbon. That's the rule because of its valency. So if you count the bond around this carbon, it is 1, 2, 3, 4. So you cannot add another bond because adding one there, meaning you are going against the valency of carbon. So this is how it is drawn. So also when you are drawing compound, after you have added a double bond, be careful of number of bond or number of hydrogen you are going to add to it. So now this is what we have. Again, the first rule says identify the longest continuous carbon chain. So the longest, obviously, is going to be 1, 2, 3, 4. If you also go like this, 1, 2, 3, 4, that's also 4. So let's just take this one that is on the straight line. So we are going to take this one as our longest continuous carbon chain. Now, the second thing says that you are going to identify a substituent. So these are the substituents we have here. All of that, they are all hydrogen. So these are our substituents, CH3. And we know CH3 to be what? A methyl. So this is a methyl. So from there, you must number such that this substituent, and in this case, we have a unique functional group, which is the double bond. This double bond must take the smallest number. So if we start from here, 1, 2, 3, 4. And then from the back, 1, 2, 3, 4. In fact, when you have a functional group, take note of this. When you have a functional group and when you have a substituent, consider your functional group first. It's just like you have elders in a meeting and then you have children and you want to serve food. You're going to think of the elders first, not even the children. So it is what is left, that's what the children will feed on. So that's a very important rule. Don't always start thinking of the substituent for a functional group. Think of the functional group first for a substituent. Anything the functional group take or decides on is what the substituent are going to use. Now take note. Now let's go. For the functional group, which is double bond, 1, 2, 3. Immediately after carbon 3, we are going to see. Immediately after carbon 3, we are going to see this double bond. But from the back, immediately after carbon 1, we are going to see double bond. So here is carbon 3, here is carbon 1. So which is smaller? Obviously it's 1. So we are going to use 1 in the numbering here. So I'm going to take off the forward numbering. So I'm going to take off that forward numbering. So we have this right now. So we have this 1, 2, 3, 4. Now in naming this, we are going to name the parent. This is the parent name first. So we have 4 carbon atoms. Remember, 4 is what? A boot. Now this double bond is after carbon 1 and you must indicate it. So it's going to be a boot 1. Now the family name is alkene, but you are not going to add this ALK, you are going to add this ANE. So it needs to be a boot 1 in. Or we can also call it a butene without the 1. Butene. Any of them is correct. But this is more appropriate. So boot 1 in, telling us that there's an hyphen here. Telling us that this double bond is after carbon 1. After carbon 1, you get to see your double bond. But after carbon 3. So that's a boot 1 in. So the only substance we have here is a methyl, and methyl is on carbon 2. Like I told you, it's whatever this one says, that's what everything we use. So our final name is going to be a 2-methyl, boot 1 in. So this is more appropriate. So we can write as 2-methyl butene. But any other number apart from 2 must indicate it. But sometimes when it's 1, we choose not to include it. But this is more appropriate. So I can write as 2-methyl boot 1 in or 2-methyl butene. Both of them are both appropriate. So now that is just for that. So again, your longest continuous carbon chain number such that your functional group, because in this case we have a very unique functional group, which is the double bond. So it must take the smallest possible number, and then you name your substituent, and then that's all. So let's take another example. So let's take this example here. So I'm going to draw this example. If you are watching right now, so I will implore you to attempt this example and then leave your answer again in the comment section. So let me get an example and then we'll name it. I think this is a very good example to take. So I'm going to clean this. So with this example, we have right here, we have this to be a CH3, a CH2, a C, a CH3, double bond C, CH3, single bond CH3. So this is the compound we have. So if you are watching this video right now, I will just implore you to attempt this question and then leave your answer in the comment section. Okay, so I think some answers are in the comment section right now. So I'm going to name it and then you assess yourself and tell if the answer is correct. Then somebody asked about benzene. We might not be able to take benzene in this class, but probably in software video lessons, you get to see the video on benzene. So now let's name and see if you are correct. So now this is a compound again, almost in the condensed form. So it's best you expand it, but then with time you can name this compound just as it is. But let's just expand it. So we have a C with an H, with an H, with an H. Then we have a CH2, H, H. Then we have this carbon here. To this CH3 down here. To this CH3 again down here. To a CH3. So some person might wonder, why is this place blank? Like I told you, okay, there's a double bond here. So somebody might wonder, why is that place blank? Remember, 4 bonds always surround carbon. So to this carbon, we have 1, 2, 3, 4. Similarly here, we have 1, 2, 3, 4. So 4 bonds will always surround carbon. Very important. So now, with this, we can add name. So let's name from the front and then we'll name from the back. So this is a 1, 2, 3, 4, 5. Then from the back, we have 1, 2, 3, 4, 5. Now from the forward numbering, 1, 2, 3. After carbon 3, you see a double bond. But from the backward one, after carbon 2. So here, after carbon 2, here after carbon 3. So you're going to ask yourself, which of them is the smallest? Obviously, it is 2. So you're going to use our backward numbering, because our backward numbering gives us the smallest possible number. So I'll take this off, take this off, take this off, take this off, and then take this off. So that's what we have now. So now, on this case, our double bond is immediately after carbon 2. So let's name this compound first. We have 5 carbon atoms, and 5 is a pent. So this right will be going to be a pent. Now this double bond comes after carbon 2, so it's going to be a pent2N. So that's the parent name, a pent2N. Now when you are done with that, you now identify your substituent. These are substituents, CH3 and then CH3. So they are both CH3, but one is on carbon 2 and the other is on carbon 3. So this is going to be a 2, 3. they are both methyl. Two of them, that's going to be a dimethyl pent 2 in. So this is a 2,3 dimethyl pent 2 in. So this is how easy it is to name compound. So what you know is that you must first of all be able to locate the longest continuous carbon chain, and then when you have done that successfully, you identify your substituent and then number so that either your functional group, which is the main thing, or then substituent, get the smallest possible number. And also you must also name it alphabetically. So once you have done that, you should be able to name any compound you come across as far as alkene, alkyne, or any other family in a very easy manner. So let's look at another example. There's a beautiful example in the jam pass question. So let's take that example. So I'll draw the example there. If you can name it, I implore you to please name that compound. So this is what we have. So I'll just take the structure of the board. So this is what we have currently. We have this structure. It's a big structure. So we have a CH3, but don't let the big name scare you. So this is a C, this is a CH2, this is a CH3, it's a double bond CH here, CH, CH3, and then CH3. So this is the compound we have right here, CH3 to a C to a CH2. So this is a compound. So you are going to name it, but if you can't do it, to quickly drop your answer in the comment section while I'm naming. So now let's go. So somebody might decide to expand the structure. So let us do that. So we have the CH3, CH3, C, CH2. Okay, let us draw this one and expand it from H, H. Then B, there's a CH3, H, H, H. Now, there's a double bond here. There's a CH. There's a CH again. Let me just put this H down, but there's a CH3 above it. Then there's a CH3. Now, I like this example because it clearly tells us something. And that's our first step, which is naming of the longest continuous carbon chain. But I told you, some students will just assume that this is always the longest chain. That's totally wrong. Your longest chain must not always be horizontal. Your chain can go like this. So you must count first. So now if you look at something, this is first. If we go like this, we have 1, 2, 3, 4, 5. That's 5. If you go upwards, we have 1, 2, 3, 4, 5. That's also 5. Now if I decide to go, let's say there are so many ways you can go, but the key thing is that it must be the longest. Now 1, 2, 3, that's 3. Now but see something. 1, 2, 3, 4, 5, 6. So this is the highest. The others we counted was 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4, 5. So the highest is 1, 2, 3, 4, 5, 6. So this is going to be your longest continuous carbon chain. So I'm going to circle this out. So I have this now. We now have this to be the longest continuous carbon chain. So please, from this particular example, you cannot learn that your longest chain must not always be horizontal. It can take any form, but the key is that it should contain the highest number of carbon atoms. So now we have 6 here. That makes it an hex. 6 is hex. But now let's number so that in this particular chain, we have this as double bond. So let's number. So this is 1. So let's start from down up and from this way. So we have 1, we have 2, we have 3, we have 4, we have 5. Oh, I missed that. So it's to this end. Then we have 6. From the back, we have 1, we have a 2, we have a 3, we have a 4, we have a 5, and then we have a 6. Now from the forward numbering 1, 2, 3. After count 3, you get to see your double bond. From the backward 1, 2, 3. After count 3, you get to see your double bond. So with this numbering, both the forward and backward, they are equal. 3 from the front, 3 from the back. So, but then you are going to identify your substituents. Now, this is one of our substituents. This guy here, CH3, because it's outside the chain, and then CH3 also. So those are the substituents we have. So if you look at substituent, with this 4 numbering, we are going to have 1, 2, 3. This is going to be on carbon 3. This is going to be on carbon 5. So the 4 they have something as 3, 5. Then from the back, we have 1, 2, 3, 4. So we are going to have 2, 4. So since we are okay, since from the front and from the back, we have 3, 3 for the double bond. So let's move with another number, which is for the substituent. So again, let me just emphasize, for this double bond, either the forward or the backward is the same. So that's not really changes nothing. So now let's come to our substituent in this case. Like I said, when the elders have eaten, then the children can eat. So now this is okay. So this guy says, well, I'm okay with any of them. Just allow the children to pick something small. So what happens if we go from the front to the back? We are going to have 3, 5. This is on carbon 3, this is on carbon 5. But from the back, so that's where we have this 3, 5. But from the back, we have 1, 2, 3, 4. It's going to be 2, 4. Obviously, 2, 4 is smaller than 3, 5. So I'm going to make it of these 2, 4. So I'm going to clean the forward numbering. So I'm going to take this up, take this away, take this, take this, take this. So I'm going to use this. So now in naming, we have this methyl on carbon 2, and then we have this methyl on carbon 4. So this compound is going to be a 2, 4 dimethyl. Now, how many carbons do we have when we counted? The longest chain has 6 carbons. So 6 is an hex. Now, either from the front or from the back, this double bond is after carbon 3. So it's going to be an hextene. So the final name to this compound is a 2,4 dimethyl hextene. So as simple as that. So if you have any questions, please write to leave in the comment section. I'll check the back end right now for any question. So in the absence of any question, we will move on to the other homologous series. We are going to look at the alkyne now. After we should proceed to other families. So let's go. So the third family we are going to look at is the alkyne. So let's take a good look at what we call the alkynes. So we have the alkyne. So the third is the alkynes. And what is unique about the alkynes, their functional group is the triple bond. Triple bond. Here you see the triple bond. So their general molecular formula is the CnH2n-2. That's their general molecular formula. So the way you name alkene is just similar to the way you name alkyne, such that you must target this triple bond and give them the smallest possible number. In fact, it's always on carbon 1. You see that it's at the beginning or at the end. So you can never see it at the middle. So wherever you see it, you must start numbering from there. So wherever you see it, if it's at the front, you must start numbering from the front. If you get to see it at the back, you must start numbering from the back. So it's simple. So let's take some questions. So let's take a look at some interesting questions. Let me quickly scan through it and get to see questions. Okay. So in the inability to cite questions, let's just take a look at some pretty examples. So let's say we have something like this. So this is a compound. Some person might be wondering, now your exam, you could be given as CH triple bond. So let me just show you how to draw CH. Let's say this is CH3, or let me put it down. CH3. So you should know how to draw. This C is the C. This is attached to one hydrogen. So following it is a triple bond to another carbon. Following this carbon is another carbon with a single bond. There's an hydrogen attached, that is hydrogen. Beneath it, there is a methyl attached to a CH3. CH3 means a carbon with 3 hydrogens. So that's all in expanding a condensed formula. Now, something very important is this. Now, somebody again might be wondering, why is this place blank? I've said this over and over again. A carbon atom is only surrounded by 4 bonds. So if you look at this particular carbon atom, you're going to see that there's 1 bond, 2, 3, and then 4. Same for this one, 1, 2, 3, and then 4. So 4 bonds will only or must only surround carbon. Now, like I said earlier, this triple bond can only be in 2 locations. 2, either it's at the beginning or at the end. It can never be at the middle. It's either it's at the beginning or at the end. So this is beginning here. We are not talking about this carbon to hydrogen or the carbon to carbon. So it must always be at the beginning carbon to carbon or at the end. So it can never be at the middle. So now let's name this compound. Now can number from left to right or from right to left. Is that true? No. You can only number. You must start numbering from where it begins from. So we are going to start numbering from where you have your double bond, your triple bond rather. So this is 1, 2, 3, 4. So we have done that. Now this is the longest chain, a boot. So we are going to name this as a butene. Just call it a butene. There's no need for the 1 because it must always be on carbon 1. So just a butene. Then when you have done that, locate your substrate. Obviously, this is the substrate we have here. And that's the methyl, and it's on carbon 3. So final name to this compound is a 3-methyl butene. 3-methyl butene. That's the name for the compound, 3-methyl butene. Now, let me give you a compound to name on this particular structure. So let's say we have something like this. So just place your answer in the comment section. So we have a CH, C, H. So let's name this compound. So if you are still on this live video, do it to name this compound and also drop your answer in the comment section. So do it to name and then give your answer in the comment section. So this is C. There's a triple bond over there. So just do it to name and then give your answer in the comment section so I can look at other families. Okay, so please do it to leave your answer in the comment section as I'll name this compound right now. So that's the compound. Now, some person may just think that this compound is 1, 2, 3, 4, a 4 long continuous carbon chain. Some person might think that this is a substituent, but if that's how you name the compound, that's a wrong way of naming that compound. So remember, it is the longest continuous carbon chain. Remember on the longest continuous carbon chain. So now you can count from here and count from here to know your longest. 1, 2, 3, 4, 5. If you count if you just use this straight one, you're going to get 1, 2, 3, 4. And then it's possible for you to have a 5 carbon atom with the fact that that's the longest continuous carbon chain. So it continues from carbon to carbon to carbon to carbon to carbon. So obviously these are our longest chain. So this is the longest chain we have right here. So we have this. We have this. So and this is a 5 carbon atom structure. So 5 corresponds with a pent. So we have a pent. And then there's a triple bond, so that's a pentyne. So now there's no substituent. So that's the final answer to this compound, or the final name to this compound. This compound is clearly a pentyne. So don't be deceived when you see something done and it quickly assumes a substituent. The first rule says get that longest continuous carbon chain. So the name to that compound is a pentyne. So I believe we have learned that right now. So let's move to another homologous series. In this case, we are going to look at what we call the alkanol. So we are going to look at the alkanol. The alkanol. So let's go. So let's take a look at the alkanol. Alkanols. So like I told you, they were formerly called the alcohol. Formerly, they are formerly called the alcohol. So whenever they are talking about alcohol, know that they are talking about alkanol. But please, alkanol is the Iupac, because what we are meant to know is what we call the Iupac nomenclature. Though you should also know the old name, but you should familiarize yourself more with the Iupac name. So the Iupac name, they are called the alkanol. Old name, they are formerly called the alcohol. And like I told you in our previous video lesson, their general molecular formula is CnH2n plus 1 OH. So this is their general molecular formula. And I also told you that this guy here stands for an alkyl. So that's why this guy can refer to as an ROH. ROH is an alkyl. So now let's look at how to name some basic compounds. So let's take a look at this. Let's say we have something like this. And then what's their functional group? OH. So once you just see OH in a compound, that should just be a pointer that this is an alkanol. You should not start thinking too far. That's an alkanol. Just like what I said, all single bond alkene. You get to see a double bond alkene. You get to see a triple bond. That's an alkene. So take note of that. Now also know that in some cases you could see more than 2 double bonds. That's why we'll talk about functionality of double bond. We are going to talk about that one. So some double bonds are higher than the other one. So we are going to talk about that one very soon. So this is an OH, this is an H, this is an H, this is an H, this is an H, let's say this is an H. Then I'll show you something about functional group, very, very important, where I'll put an alkene and an alkyne in the same group. So we are going to look at it. So now this is a simple example of an alkanol. So what we just have here, we have no substituent. We only have 2 carbon atoms, no substituent. So 2 is what? An it or et. So that's an et. Now add the family name, remove this ALK, then add the other thing. It and null. So please let me remove this. So that's an it and null. It's as simple as that. So let's take another example. So let's say we have this, look at this structure. So we have this OH. Now this OH can be here, this OH can be here, this OH can be at the middle. Now that's very, very important. So we are going to take some examples. So let's take something like this. CH3, H, 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 H. So that's basically what we have. Now take a look at something. This is a compound. Now, if you look at this compound, something should first catch our attention. And what's that thing? This OH is functional group. So this is what we have here. So this is our longest continuous carbon chain. But let me take it. OH. So I'm meant to take it through here. So that's our longest. And our longest have 3. So 3 is prop. So that's a prop And then we are going to add this family name, anol, prop, anol. But after we've named that, then we have something which is a substance, and that substance is CH3. And CH3 is methyl. Now, we know that we have a methyl, but what's the position? Now, you must start your numbering from where you have your function so that you can have the smallest number. So we are going to number like this: 1, 2, 3. So that's the number we are going to use, so that this one can take the smallest number, which is 1. Because if you go from the front, we are going to have something like this: 1, 2, 3. So we are going to give this number 3, but 1 is smaller. So obviously we are going to use number 1. So with that, we are going to use this forward number. So let's take off. So we are going to use it backwards rather, not the forward. So with the backward numbering, methyl is carbon 2. So that leaves us with the answer of 2-methyl propanol. 2-methyl propanol. So that's how this structure is being named: 2-methyl propanol. So now let's take another example. Now take a look at this example. Take a look at this example. Now let's say we have H, we have H, we have H, we have H here, but then we have something shocking, but not really shocking. We have an H and then we have an OH. Now, something very important, this could be a propanol. Some persons will tell us that, oh, the person is just to be more specific. They will want to tell that this is actually on carbon 1, so they could best write it like this: 2-methyl propan 1-ol. So that's the more accurate way of writing it. But it clearly tells us that the functional group OH is on carbon 1. So that's a better way of writing it, because this OH can be on this, can be on this, can be on different carbon atom. Now this is a good example. Now if we look at this structure, we have no substituent. So let's take our mind those substituents. These are functional group OH. Now if you number from the front, we are going to have 1, 2, 3. Then if you number from the back, we are going to have 1, 2, 3. So either ways, forward or backward, this functional group will be on carbon 2, any of them. So you can use any of the numbering. So how are we going to name this? It has 3 carbon atoms, 3. And 3 is what? A prop. So this is going to be a prop, propan. Either way is on carbon 2. So I'm going to write a propan 2-ol. So this is the name to this particular compound: propan 2-ol. So let's take 2 more examples and then we'll move to the next family. Now look at this example. Now look at, let's say we have something like this. We have an OH right here. We have an OH. Let's say we have an OH. Let's say we have an H and H. And then let's just add the CH3 to this side, and then let's add an H, and then let's add an H. Let's say we have a structure like this. Now when you look at a structure, we have 3 carbon atoms. That is the longest continuous carbon chain. So technically, we have this. Let's say we have 1, 2, 3. On the back, we have 1, 2, 3. So, and when you look at this, we have OH on 3 different carbon atoms. We have an OH here, we have another OH here, and then we have another OH here. OH on 3 different carbon atoms. So OH, OH, OH. So meaning even if you go from front to back, you're going to be 1, 2, 3. From back, 1, 2, 3. So it solves the same thing, forward or backward. But then we have a substituent, and then these are substituents right here, which is a methyl. So let's name that methyl. So the methyl is on carbon 2 in any way. It's going to be a 2, or let's use the black ink. So that's going to be a 2-methyl. It's going to be a 2-methyl. 2-methyl. Now for the parent name, we have 3 carbon, and 3 is a prop. Now this here it becomes interesting. Now we have OH on 3 different spots, so we must indicate it. We must tell the position. One is on carbon 1, carbon 2, and carbon 3. So this is going to be a propan 1, 2, 3. So tell us that there's an OH on carbon 1, on carbon 2, or carbon 3. Propan 1, 2, 3. Now we have 3 of this OH, and 3 is what? A tri. Remember, di is for 2, tri is for 3, and then tetra is for 4. So this is going to be 1, 2, 3, triol. Triol. So that's how we name this compound. Now I'll drop a compound right now on the board. Name this compound and leave your answer in the comment section. So now this is what we have. We have something like this. OH, H, 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 OH. So attempt this question and then leave your answer in the comment section. And then I'm going to solve this or name this compound for you. When I come back, we are going to name both compounds. And then we'll move on to the next homologous series. So we're going to look at how to name this compound. So when I come back, I'm going to name both compounds. But please try to leave your answer to this particular question in the comment section. And if you have any question or anything you want us to name, just leave them in the comment section, or probably to draw a structure, also leave them in the comment section. And if you are new and you're watching this video for the very first time, or you're coming across this live video, please try to click on the subscribe button and also turn on the notification bell so that whenever I release any video, you will always get notified. Okay, so I've seen a lot of comments. Yeah, I saw a name. Someone wrote ATHAN. So I guess you are trying to write ETHAN. But please let me know where you are watching this video. Please just drop your location in the comment section of this video so that I'll know if there are peculiarities to your particular location. But a 2 carbon atom is rightly referred to as an ETH. ETH. Probably in your location it's an ATHAN, but the English curriculum takes it as an ETHAN. So now let's name this particular compound. Now we have 2 carbon atom, and on this carbon atom we have this OH. Like I told you, the first thing that will capture your attention is your functional group, because that decides how that compound is going to look like. Your functional group is very, very key. So you don't just start naming the compound because you want to name the compound. Even if your functional group is at the bottom, locate it first. So these are our functional groups. We have an OH here, and then we have an OH here. And this clearly tells us that this compound is an alkanol. So we are going to name this as an alkanol. So now that's an OH and another OH. So we are going to name that. Now you are going to number. So if we number from front to back, we have, let's take it as 1 and then 2. From back to front, we have it as 1, 2. So either ways, it changes nothing. Both of them are still on 1 and 2. So in this case, we have 2 carbon atoms. So for a 2 carbon atom, we are going to rightly refer to it as an ETH. So this is going to be an ETH, ETHAN. We have one of them on carbon 1 and the other on carbon 2. It will be 1, 2. Now, because we have two of this functional group, we are going to write a diol. So this is going to be a diol. So it's an ethane 1,2-diol. So take note of that. Remember, you have just two carbon atoms, two of the functional group, one of carbon 1, one of carbon 2. So it's going to be an ethane based on your two carbon atoms, position 1 and 2, two functional group, a diol. If you have 3, it's a triol. If you have 4, it's a tetraol. Now let's come back to this particular compound. Like I told you, there's something very, very important, and I want to let you know about this. Very important. Please take note of this. We have a lot of functional groups. We've talked about the alkanol, there's the carboxylic acid, there's the alkanon, there's the alkana. There are a lot of functional groups. There's even this triple bond, there's double bond. Now, in a compound, you can see like two different functional groups. Two. I think after this one, we'll take another example just to illustrate. You can see two different functional groups. Now, one of them must stand as the head. There's a particular code that says that two captains cannot sail a boat. So when you have two captains, there's definitely going to be trouble or issues. So one must act as the head, then one must act as the assistant. So now when you have two functional groups, it could be more than two functional groups, one must be the head, and that head is what will form the parent name. Very, very important. And how do you know the head? It's very easy. When you calculate what we call their molecular mass, the one with the highest becomes your head. For example, let me give you a good example. Let's say we have COOH. Let's say we have COOH in a particular compound, and then we have OH. We have COH, and then we have OH. I'm going to show you an example when we look at the next family. COOH. If you calculate the molar mass, carbon is 12. So let's just do a bit of the calculation here. So carbon here is 12, oxygen is 16, the other oxygen is 16, plus hydrogen is 1. So when we add up, this is going to give us 28, then 28 plus 16 is going to give us 44, plus 1, that's going to give us about 45. So for this OH, this is 16, then this is 1, and 6 plus 1 is 17. So if you get to see a compound that have both functional group, this is going to be the head, because it has the highest molecular mass. So take note of that. So when you are naming, the name should contain this as the parent, then this is automatically going to be a substituent. Just like you have three rich men, one has about 1 billion, another one has about just 1 million. They are rich, but one is higher than the other. So we are going to acknowledge the one with 1 billion before we talk about the one with 1 million. So that's what happens here. So when you have multiple functional groups, acknowledge the one that is higher in mass than the other one. But when you have a double and a triple, acknowledge this triple before the double. So how do we name this compound? Very important. The longest continuous carbon chain has how many carbon atoms? 5. So this is a 1, 2, 3, 4, 5. But remember, this is higher than this. So I'm going to name from the back in this case. So I'm going to use 1, 2, 3, 4, 5. So I'm going to take this off, take this off, take this off, take this, and take this away. So now, when you take that, immediately after carbon 1, you get to see your triple bond. 2, 3, 4. After carbon 4, you get to see your double bond. So how are we going to name? It's very easy. 5 carbon atom. That's going to be a pent. Pent, P-E-N-T. Now you are going to talk about this one first. This is going to be the last. So pent. After carbon 4, you see your double bond. So you are going to say it's a pent 4 in dash. After carbon 1, you are going to see your triple bond. Ine. Because in is for double bond and then ine is for triple bond. So this compound is a pen 4 in 1 ine. So that's the final answer to this particular compound. Now let's take a look at another example so that you get to understand the concept of multiple functional group. So let's take a look at this example. So let's say we are given a compound, and in this compound we have something like this. OH, and then let's say we have H, and then I'll just add a substituent. Let's say we have CH3, and then let's say we have H right here, and then H right here. So I believe we now understand why there's no H here, because like I told you earlier, 4 bond, we always surround carbon. So to this carbon, you have 1, 2, 3, 4. So this one you have 1, 2, 3, 4. So don't ever think of adding something here, or don't think that the question is wrong, because these places are empty. So if you look at this carbon, you have 1, 1, 2, 3, 4. So that's 4 bonds rather. So now if you look at this compound, you have 2 different functional groups. Now is what you now look at what we call functionality. Which one comes before the other one? So one is always higher than the other one. Obviously, these 2 guys are lower than any other functional group you can see. So these multiple bonds are lower. In fact, they are the lowest part. So at the lowest part, triple bond is higher than double bond. So automatically, the lowest will be an alkane. So triple, double, and then single. From there, you can now have the other ones based on their masses. So it's very easy. So for other functional group, except this bond, they are higher than this bond. So you can have others, and you arrange them based on their mass, based on their molecular mass. Then when you now come down to the bonds, triple bond is higher than double bond, and the double bond is higher than single bond. So that's just a very easy way of doing that stuff. So now that's that for that. Now let's name this compound. In this compound, we are interested in these 2 guys. This one with functional group OH, and then this is another one, a double bond. But in this case, obviously, OH is higher than the triple bond, than the double bond rather. So we are going to look at it and then name the longest continuous carbon chain. So this is the longest. In longest, we have 3 carbon atoms. 1, 2, 3. Now remember, when numbering, you are going to number so that your main functional group in this case is going to take number 1 or any smallest number. So in this case, this is going to be a 1, 2, and then 3. 1, 2, 3. So now we are going to name, but before we do that, there's a substituent, and this is substituent CH3. So while doing that, let's name correctly. So this substituent is on carbon 2. So this is going to be a 2-methyl. Now we have 3 carbon atoms, which is a prop. Now something very interesting here. We have a double bond, and double bond is after, look at it, this is carbon 1. After carbon 2, you see your double bond when you are coming from this backward number. So it's going to be a prop 2 in. Then our OH is on carbon 1, so it's going to be a prop 2 in 1 all. That's one way of naming this compound. Another way is like this. It's going to be a 2-methyl prop. Some persons will add the in and the all together to create a propanol instead of a propanol. So they will call it in with the all together. So it's going to be a 2-methyl propanol. But the better way is that separate them. Tell us that the double bond is after, it's after carbon 2, and then the OH is on carbon 1. So this is a more appropriate way of writing the name. But in an exam, if you see this, then that's fine. But this is more appropriate. So in a more appropriate way, it's a 2-methyl prop 2 in 1 all. That's simple. So if you have any questions, please always go to leave them in the comment section. I will attend to all questions. And please also do let me know where you are watching this live video from. Thank you. So in the absence of any question, we'll move on to the 5th family, or the 5th homologous series, which is the alkanoic acid. So let's go. So we are going to look at the alkanoic acid right now. So number 5, the 5th family we are going to look at is the alkanoic acid. So we call it the alkanoic acid as the Iupac name, but they were formerly called the carboxylic acid. So the old name for them is the carboxylic acid. So that's their old name. Now something very interesting. Now let's go. Now, alkanoic acid or the carboxylic acid, and their general molecular formula is this. So let's take this. Their general molecular formula is CnH2n plus 1 COOH. So if you followed our last class, I told you that the functional group for the carboxylic acid is the COOH. Don't forget that. So this is the functional group for the carboxylic acid. So, or you can also see that as everything here stands for alkyne. So that's the arrow COOH. So now let's look at how to name compounds that have a carboxylic acid. Now, just like alkyne, ALKYNE, the triple point is always at the end, either at the beginning or at the end. So also this carboxylic acid COOH is always at the beginning or at the end. You can never find it in between. So let's say we have something like this. Let's take a simple example of a structure. OH, H, H, H. So this is a compound. Now, how do we name? It's a very easy thing to do. The longest chain here has just 2 carbon atoms. And when you take a quick look, and even before you take a quick look, like I told you, always locate your function. That's the first thing. So you know where you are heading to. If you take a quick look, you find out that there's a COOH. Sometimes they may not write it together as COH like this. So you have to use your eyes and decipher what has been given to you. So this is a C. So this is your functional group here, COOH. That's a functional group. Now, while doing that, your longest chain here has 2 carbon atoms. So let me just take it. Let's go with that. So this is your longest chain, 2 carbon. 2 carbon is the prefix for 2 carbon is an eth. So this is an eth, ETH. Now, this compound contains the carboxylic group. And so you're going to add the family. The family is everything from here. Remove the ALK as we have been doing since and add everything here. So this guy is called an ethanoic acid. So for this compound, you must add the name acid because they behave like an acid. So let's end at that. So now let's take a look at another one. Let's say we have something like this. So we have this compound over there. Now again, the first thing, you must identify your functional group. That's the first thing you should do. So these are functional group without wasting time. That's our functional group. That's COH. So while we are able to do that, we will clearly know that that's an alkanoic acid. So whatever name we are going to give to it at the end of the day should be alkanoic acid or anoic acid. So the longest chain, so this is the longest chain. The longest chain here has 3 carbon atoms. So 3 carbon atoms is a prop. So we can rightly call the parent name a propanoic acid. But we'll get to see that there is something else which is a substance. So we have a substance right here. And that substance is a methyl. So we are going to name it. Like I said, this must always take the smallest possible number, or that is general rule, not like I said. That is general. So general is that your functional group must take the smallest possible number. So you are going to number, we are going to start numbering from here. So this is going to be 1, this is going to be a 2, and then this is going to be 3. So when we do that, we now see that methyl is for carbon 2. So final name, this compound is a 2-methyl propanoic acid. So it's a 2-methyl propanoic acid. So that's how easy it is to name this particular compound. So now let's take a question from the jam pass question. And then if you can attempt it, do it to leave the answer in the comment section. Also, if you are watching this live video, do let me know where you are watching this live video from. So now let's take a look at, there's a good example I saw right here. So this is a compound for you, very easy. So we have this. So we have this compound right here. So we have this as CH3, CH2, and then we have that C double bond O, double bond OH. So this is the first question. You can attempt it. Now let's take a different question that contains the OH. Okay. The other question, I'll have to clean that other part. Then I'll take this up so that we can have space to draw. So to this we have a CH3, we have a CH2, we have a COOH. So this is the first question you can attempt. Do it to attempt it and then leave your answer in the comment section. Then the next question we are going to take a look at is this. So let me clean this off. So the other question we have right here is okay, good. This is what we have. So we have something like this. We have a CH3, 2. So let me write this properly. So this is CH3, 2. We have a CH, we have a CH, we have a C double bond O double bond single bond OH, and then we have a CH3. So those are two compounds we have. So you can do it to name this compound and then leave your answer in the comment section of this video. I will attempt to all comments shortly. So do it to name and then leave your answer in the comment section of this video. Now if you are watching this video after now, just wait to pause the video lesson. So in the absence of any question, we'll go ahead and name this compound. So for this first compound, it's an easy compound, but if you choose to stretch it or draw it in an expanded form, then that's good for you. So then this is CH3, so we have H, H, H. Then this is CH2, H, H. Then we have a C here, double bond O, OH. Now we are going to name this compound. Now we're going to name it. Very easy. So now this is just a 3 carbon atom or a 3 carbon chain. So 3 is a prop, and we have no substituent or hydrogen. This will be a prop. This is the functional group here, COOH. So the final answer is going to be a propanoic acid. So that's the final answer to that question. So that compound is a propanoic acid. Then let's look at that big guy we have over there. So let's take a look at it. Now I'll start drawing from the back, because some person may look at this way. Like I told you, when you see something like this, draw from where you feel is simple, and then draw to the side you feel is complex. So we are going to start drawing from here. So this is COOH. Obviously, this is the functional group. So we have C double bond OOH. Then come here, C with an H up here. Then CH3 down here. Then this is C to an H. Then next we have a CH3. Now the chlorine package they put 2, it means you have 2 of this one attached to this carbon atom. So I have 1 here. So let's attach 1 to this one. H, H, H. So this one CH3, then you have the second one attached to it. H, H, H. Simple. Or I can just write it as CH3. So we have expanded the structure. So the next thing you do is that you're going to identify the longest continuous carbon chain. And by so doing, this gets to be your longest continuous carbon chain. So that's it. So the next thing you identify your substituent. So this is one of our substituents, and then this is another substituent outside here. And then you're going to number such that this functional group must take the lowest, and it's always going to take number 1. So let's number now. So we have 1, we have a 2, we have a 3, and then we have a 4. Now these two guys, they are both methyl. So now let's name. So we have a methyl carbon 2, we have another methyl carbon 3. So clearly this is going to be a 2,3. Because we have 2 methyl, it's going to be a dimethyl. Now 1, 2, 3, 4. 4 carbon is a but. The final answer is going to be a butanoic acid. So the name of that compound is a 2,3 dimethyl butanoic acid. So that's how easy it is to name organic compound. So that's just what you want to know. So the rule is simple, and we are just still deriving these rules from the basic or from the first the general rules for naming organic compound. The first says identify the longest continuous carbon chain, which gives you the parent name. Secondly, you must identify your substituent, and like I say, substituents are things that are not hydrogen. Then the third thing is that you must number such that the functional group first of all, and then the substituent can take the smallest possible number. And then when writing your name, you must number them alphabetically. And then lastly, we said use 2 for things that are di, use 3 for things that are tri, and then so on and so forth. So now let's move on. So we are done with alkanoic acid. The next we are going to look at is what we call alkanal. So let's look at the alkanal. So we are going to take a look at the alkanals. So the alkanal. So let's take a look at it. So the 6th family we are going to take a look at is the alkanal. Now, take note, the alkanal, they were previously called the aldehyde. So they were previously called the aldehyde. Now, their general molecular formula is what referred to as CnH2n plus 1 CHO. Remember, this is an alkene, so we can write it as the arrow CHO. So to remember the alkanal, just say CHO. That's CHO, CHO. That's to tell us this is the alkanal. So when you see the CHO, you just know, and how is it drawn? You have a carbon, so this is a carbon. It's attached to an hydrogen, whether either up or down, then to an oxygen. When you see this CHO, just know you can also be drawn like this, O up, H down, but all the same, that's CHO, that's an alkanal. So let us take some few compounds and then we'll move to the next family. So let's say we have something like this, one bond O. Now if you find out something, you get to see that we are drawing 2 bonds to oxygen, because that is the rule. The rule is that oxygen has a valency of -2. That's 2 minus. So the 2 minus tells that 2 bonds will always go to oxygen. For something like hydrogen, hydrogen is just an H plus, or a plus 1. Tell you that one bond will go to hydrogen. Something like nitrogen can be a -3. So it tells that 3 bonds will go to nitrogen. That's why when we draw cyanide, cyanide is drawn like this: 1, 2, 3, N. Because 3 bonds must go to nitrogen. So don't be surprised. Why are we adding? Why is it 2 bonds to oxygen? Or why is it 1 to hydrogen? Or why is it 3 later? We find out to nitrogen. It's just from their valency. So O2 minus tells that 2 bonds must go to oxygen. H plus 1 bond must go to hydrogen. N3 minus 3 bonds will go to nitrogen. So now let's just name 2 compounds under alkane, and then we'll move ahead to other families. So this is the compound we have here. The rule is simple. Your functional group must be identified first, and your longest continuous chain must contain that functional group. So obviously, this is going to be the longest continuous carbon chain. And again, this guy is always on carbon 1. The alkyne function is always on carbon 1. So in this case, we are not really going to use our number 1, 2, 3. So we are not using this numbering system, but just know that this must always take carbon 1, just like alkanoic acid must take, the functional group must take carbon 1. So now in this case, we have 3 carbon atoms, and 3 is referred to as a prop. Now we are going to add the family name, which is the anal. So this is going to be a prop anal. Simple. So let's take another example, and then we'll move to another functional group. So let's say we have it in this case at the front. So this is the family we have. Now we are going to name. First of all, you must know that this is the functional group, and you are going to identify your longest. So obviously, this is going to be the longest functional group. And longest contains 4 carbon atoms. But mind you, we have a substituent here. So let's number. This is 1, this is 2, this is 3, and then this is 4. So when we have done that, we find out that this is a methyl, and methyl is a carbon 2. So name for this is going to be 2-methyl. 2-methyl. 4 carbon is a boot. It has the alkyne functional group, so you're going to get a 2-methyl butanol. So this is the name to this particular compound. So please, if you have any question, any comment or suggestion, try to leave them in the comment section of this video. And if you are watching this video for the very first time and you haven't subscribed to this channel, try to click on the subscription button somewhere around that video lesson. And also let me know where you are watching this video from. Thank you. So the name to this compound is a 2-methyl butanol. So let's move to the 7th family, which is the alkanone. So let's go. So the next we are going to look at is what we call the alkanone. So the 7th one we are going to look at is the alkanone. Now the alkanone, they were previously called the ketone or the ketones. So they were previously called the ketones. Now what the functional? The functional for this is what we call CN, or it's what we know as the CN H2N plus 1, CO CN H2N plus 1. So the main thing here is that a functional group CO. So this is general molecular formula, but the functional group is this CO. So in some cases, this is an alkene, this is an alkene. So we can also write it as arrow CO arrow. So the major thing is this functional group. And please take note, for the purpose of exam, very, very important. When a carbon is double bonded, we need something like this. Or let's take this further. When a carbon is double bonded to an oxygen, we'll call this thing a carbonyl group. Carbonyl group. So take note of this. In the UTME, I think this question has been asked before. A carbon that is double bonded to an oxygen is called what? The answer to that question is actually a carbonyl group. So now let's go back to this family. So now for this family, let's just take a look at some example. Now for this particular functional group, that is carbonyl functional group, it can be anywhere. It's not like alkanoic acid or the alkanol that must be at carbon 1, either at both ends. This can be at carbon 1, carbon 2, carbon 3, can be anywhere. So you must tell us where it is when naming. So let's take a look at some examples. So look at something. So that's what we have. Now let's take a look at how to name this particular compound. Now before naming that, you must identify your functional group. And obviously these are functional group. Yeah, that's this CO. So know that these are functional group. Then your longest continuous carbon chain is going to be this one. Now let's number. Now we can number from front to back, or from back to what? Front. So from front to back, we have this as carbon 1, we have this as carbon 2, we have this as carbon 3, and we have this as carbon 4. Now from back to front, this carbon 1, this carbon 2, this carbon 3, this carbon 4. So that's how we are going to do that. But now remember, your functional group must take the smallest possible number, smallest. So from front to back is going to fall on because this is our functional group. So let's just mark it. So this is our functional group, this CO, which is the alkanon. So from front to back is going to be the second carbon. Then from back to front is going to be third. 2 and 3, 2 is smaller. So we are going to take that 2. So I'm going to clean up the backward. Because the backward gives us an higher value. So now in naming, we have 4 carbon atoms. So 4 is what? A boot. Now this functional group is of carbon 2. Like I told you, it can be on carbon 1, carbon 2, carbon 3. So you must tell us its location. If it is on carbon 2, so it's going to be a butan 2. Now add the family name. We are already taking this arm before, we are going to add this on to it. Butan 2 on. So that's the name. Butan 2 on. Or somebody say boot 2 and on. Fine. But when I take the entire name as boot 2 and on. Any of them, but the first is more appropriate. So that's how we name. So let's take another example. So let's say we have something like this. So we have something like this here. Then we have H, we have this H too. So we have an H, we have an H, and then we have an H. Now the rule still applies. Identify your longest continuous carbon chain and it should bear your functional group. So without wasting time, this is obviously our longest continuous carbon chain. That's our longest continuous carbon chain. And now it bears this functional group. Now if you number from front to back, now let us do a quick numbering. 1, 2, 3, 4. This is carbon 4. But from back, 1, 2. So obviously we are going to use, in fact, with just a look, you find out that it is closer to this side. So we start numbering from this side. So this is going to be a 1, it will be a 2, 3, 4, 5. Now when you have done that, you notice that they are substituents in this case. This is a substituent, this is another substituent. So you must name them. And remember, when naming substituents, you must name them alphabetically. In the sense that this is methyl, and then this is what? Chloro. So now let's name. Methyl chlorine, and chlorine will come before methyl because C alphabetically comes before M. So now it's going to be a 3-chloro. So final name to this compound is a 3-chloro. Now methyl is a carbon 4. 4 methyl. 5 is what? A pent. So that's going to be a pentan. Now the functional group, which is this alkanon guy, or this carbonyl functional, is carbon 2. So it's going to be a 2 on. Simple. So it's very easy. So we have a chlorine on carbon 3. We have methyl. We have methyl on carbon 4. Then we have this functional group on carbon 2. So it's going to be a 3-chloro alphabetically because C comes before M. 3-chloro, 4 methyl, then pentan 2 on because the functional is on carbon 2. So if you have any question, please do have to leave it in the comment section. I'll see you there. Okay, so thank you, Mohit Vema. You said you have a question or a doubt. Please, can you leave your doubt or that? Can you drop that question in the comment section so that we know how to tackle it? So thank you again for the appreciation, and thank you for every other persons who have taken their time to follow this video till this very point. So I'll say you are wonderful and you have actually done well. So with this being said, we move on to the other aspect. We have to look at them very quickly so that we can save the time for this particular video. So now we have done what we known as the alkanes. So we look at other aspects. We are going to look at the alkanoids, and then we are going to look at what we call the alkoxy. So please do it to follow through. So please, if you have any question, please do it to leave in the comment section. So if you have any doubt, Moid Vema, if I'm pronouncing that name right, please do it to leave your questions in the comment section. So I'll tackle it the next time I go back to the comment section. So let's take a look at the 8th and the 9th family. So let's take a quick rundown through the rest families we have. So for the 8th one, we are going to start with what we call the arc. We are going to start with what we call the alkane. Now we call them the arc on one part, oxy. Tell that there's an oxygen. In fact, our functional group is the oxygen atom. Then there's an alkane. Now this family, they were previously called the ethers. They were previously called the ethers. So that's their own name. But their Iupac name, because we are talking about their Iupac nomenclature, they are the word, the alkane. So now let's go. Now let's take a look at these guys. These guys, they are formula with CN. So their general molecular formula is CnH2n plus 1 or CnH2n plus 1. CnH2n plus 1 is an alkyl. CnH2n plus 1 is an alkyl. So it can also be written as ROO. Like I told you, the functional group in this family is the oxygen atom. Take note of that. So now let's take a look at how these compounds look like. So I'm going to draw 4 different compounds and then we are going to name all of them. Pay attention. Now look at, we can have something like this. Please, if you have any question, please do have to leave them in the comment section so that they can be attended to. So this one, so let's take that this as our first question. Then our second one is going to look like this. So this is our second question. Then our third one is going to look like this. Then our fourth one is going to look like this. So we have 4 different compounds just for us to understand how to name the alkoxy. Because there's something unique about this family when naming them. I want to talk about that unique thing. Now, the unique thing that makes it so different from the other system or from the other families we have looked at so far is that in this case, you name what we call the smaller one before the bigger one. That's how it is named. So your name must come first. That should be your first name before your family name, which is like the bigger name. So it is first name, then last name. So that's, in this case, you name the smaller alkyl because there are 2 arc parts. There's one, please, this is an arc, not, that's an ALK, not ALX. So that's an ALK. So this is an arc. So you have 2 parts. You are going to name, go look at it. So we have an alkyl here, then you have another alkyl here. So you have 2 different alkyl. You are going to name the smaller before the bigger. So the smaller will form this part, this arc. And the bigger one will form the alkane. So now let's go. Now let's start with the second one. Then we'll come back to 1 and 2 and 3. Now, if you look at the smaller one, let's start with question 2. For question 2, we have the oxygen. Oxygen is like the dividing line or the line of symmetry. So this guy is just like a dividing line. So it separates both alkyl. So on this side you have just 1 carbon, but on this side you have 2 carbon. 1 and 2, which is smaller, obviously it is 1. So this smaller one will form this arc part. So how are you going to name? The smaller one has just 1. and one carbon, like I said, is called a met. Met. Then you are going to add this oxy, OXY. Then the bigger one will now form the alkane. The bigger one, we have 2 carbons, so it's going to be a et N. So that's why the name is on oxy-alkane. So the smaller one, or the smaller number of carbon chain, we form this arc part. Then the bigger one will form the alkane part. Very, very important. Please, you should know that. Met oxy-ethane. That's why it is named. Now let's come to question 1. In question 1, remember the oxygen is the dividing line. So this is the oxygen. And when you look at the oxygen, when you look at this oxygen clearly, when you look at opposite side, you have 1 carbon here, 1 carbon here. So in this case, none is bigger than the other one. So feel free to use any one as the smaller and any as the bigger. So when on both sides of the oxygen, both are equal, use any as the arc part and then use any as the alkene part. So let's just use one as the arc. So 1 carbon is a met, this is going to be a met, then this is going to be an oxy, then this is going to be an one again rather. So that's a met oxy-ethane. So that's how it is named. Remember, oxygen is the dividing line. So when you see oxygen as dividing line, look at what you have on one side and what you have on the other side. So the smaller one will form the arc part, and the bigger one will form the alkane part. Now let's take a look at this one. When you look at this one, oxygen again is like your dividing line. When you take a look at that, when you divide that this compound through the oxygen, you have 1 carbon here, and then we have 2 carbon here. So the smaller one forms the arc. So and 1 carbon is a met. So this is going to be a met oxy. 2 carbon is an et. So you're going to form the alkane name for me. So it's a met oxy-ethane. So it's similar to this. So it does not matter whether it's on the left side or the right side. The crucial thing is that you must name the smaller before the bigger. So this is something very unique about the family, and you should know it. Now for this one, again, let's take our dividing line through the oxygen. On this side we have 2 carbon, on the other side we have 2 carbon. So they are both equal, just like the first one. So how do you name? It's a very simple principle. 2 carbon is a met. Sorry, 2 carbon rather is an et, not met. Met is for a carbon atom. So 2 carbon is for et. So this is going to be an et oxy. Then the other is also 2 et oxy-ethane. So this is how we name these families. So the crucial thing is that name the smaller before the bigger. But in a case where they are the same, just name any of them as the smaller and any of them as the bigger. Then for those persons that are writing some exams like SSCE, UTME, GC, and other related exams, now take note of this name because it is also used in exams, and it is used when they are both equal. How do you use this name when they are both equal? When they are both equal, in this case, this is a methyl, this is also a methyl, 1-1. We have 2 methyl. So in the old name, they will not call it methoxy-methane, they will call it a dimethyl. Then you now have their old name, which is what? Ether. So in the old name, you name the methyl, you name the alkyl as alkyl. So this is methyl. So it's going to be a dimethyl ether. The same thing can also apply to this one. This one in the old name, you call it a methyl ethyl ether. That's how it's named. The same thing here, methyl ethyl ether. Now if you look at this one, if you look at this particular compound, this compound here is an ethyl. This compound here is also an ethyl. So you have 2 ethyl. So there's no need for you to write ethyl ether. Just simply write as a dimethyl ether. So take note because in some exams they still make use of this old name. So the old name, call them as their alkyne name. Alkyl. So where you have 2, this is dimethyl ether, separately methyl ether, dimethyl ether. So that's how it is named. So that is how you name what they call it, the ethers or the alkoxy alkanes. So I'll drop 2 examples and then move on to the next family. So look at this, take note of these 2 examples. So if you have any questions, please do it to leave them in the comment section of this video lesson. And also let me know where you are watching this live video from currently. So let's take a look at 2 other examples. Now we're going to take a look at these examples. Now, let's say we have something like this. So then let's take another example. Let's say we have something like this. Or then just take it as CN. So let's say we have something like this. So if you know the answers to any of them, leave them in the comment section. So I'll go behind the comment section to see if there are questions. And then someone told me that he or she has a doubt. Please try to leave that doubt also in the comment section. Okay, so in the absence of any question, we are going to name this particular compound. So now for this first one, remember your dividing line is oxygen. So let's divide this. When we divide, on this side we have 2 carbon atoms, and then on this side we have 3 carbon atoms. So the right name for this compound will be, this is a 2 carbon, which is an earth. Earth. Now on this side we have 3, 1, 2, 3. But before that, add the oxy, and then for 3 is a prop. It's going to be an earth. Oxypropane. So that's obviously clear. Now for the second one, again, pass your dividing line. When you do so, on this side we have 1 carbon atom, 2 carbon atoms. So 1 carbon is going to be a met. So it's going to be a met oxy. Now for this side, there's something very interesting. And what's that interesting thing? There's a chlorine on this side. So I'm going to name it as a chloro, whatever it is. So methoxy chloro. Now for a 2 carbon atom, it's an eth. So methoxychloroethane. So take note of this. We are adding a chlorine because there's a substituent here. If it were to be here, you can also say a chloromethoxyethane. As simple as that. So let's take a look at the last few families, and then we'll wrap up this particular session. So now let's take a look at what we call the alkanoids. So for the alkanoids, so let's take a look at the alkanoids. So the next one we are going to look at is the alkanoids. Now for the alkanoids, they were previously called the esters. So the alkanoids were previously called the esters. Now what's the general molecular formula for the esters? So let's take a look at their general molecular formula. Now the esters, their general molecular formula is CnH2n plus 1 COO CnH2n plus 1. Now for short, this is an arrow alkyne, COO. Then everything here is also an arrow. So it is an arrow, COO arrow. Now take note of this stuff because this particular family, it's almost similar. It's very, very similar to the alkanon. Alkanon is arrow, CO arrow. So this is the alkanon. So don't confuse them. This is alkanon, but this is alkanoid. So take note of that difference. Now, so in naming this, there's a unique step. The unique step is that you name this one after the CO before you name this one. So it's like you name from the back to the front. So now let's just take a look at 2 examples. Now let's take a look at this example. So let's say we have something like this. So this is just a good example of an alkanoid. So now let's name this particular compound. The first thing you should do is that identify your functional group. So these are functional group COO. So this is your functional group here, COO. So this is your functional group COO. So now when you do that, you are going to name what you have after it. Now what you have after it, we are going to name it as an alkyne. So what we have after it is C2, 1, 2. How many hydrogen? 1, 2, 3, 4, 5. C2H5 is what we call ethyl. So C2H5 is what we call ethyl. So this compound is going to be an ethyl 1. We have named that part. They are now going to name what you have just before it, including including this carbon you have there. They are going to name everything here. And what we have here is a 3 carbon atom. And 3 is a prop. So it's going to be ethyl prop. Then you are going to add this family name and know it. It's going to be a ethyl prop and know it. Simple. So the rule is simple. Name what you have after this COO. Then name everything from here, including the carbon of that COO. So the first name will give you an alkyne name. Then the other will give you the alkanoid. So in this compound, 2 carbon ethyl, 3 carbon propanoid. So it's as easy as that. So let's take another example just to get this clear. So let's say we have something like this, H, or let's take off this H. So we have something like O, H, or we have this H, we have C. So how do we name this compound? It's very easy. Now we have 3 carbon atoms. 1, 2, 3. So 2 here. So what we do, like we said, this is the functional group. So let's identify a functional group. The functional group here is this COO. So what we have after it is 1, 2, 3 carbon atoms. So I'm going to name this as what? 3 is a prop, but as an alkyne is a propyl. So the name for this compound is going to be propyl. Now we are going to now count every carbon atom, including the functional group itself, before it. So 2 there is an earth. So that's going to be a propyl earth and know it. So the rule is basic. Name what you have before and then name what you have after. So it's as basic as that. So now let's take a look at the remaining families. We'll just run through them to just give us a broad idea of all of them. So now that's just the basic stuff. So the families we have left are the haloalkane, we have the amine, we have the amide, and then we have the cyanide. So let's take a look at all of them. So we are going to just look at. So that's for the esters. And something unique about the ester is that the esters have what we call fruity smell, like the smell of fruits. So that's why they use them as what we call flavors for soft drinks and every other product that you can see in the market. So let's take a look at the others, which are the haloalkanes. Now for naming the haloalkanes, they are simple as anything you can always think of. So for the haloalkanes, now it's simple. Halo here tells that there's an halogen. And what are those halogens we have? The halogens we have, they are fluorine, they are chlorine, we have bromine, we have iodine, we have astatine, so on and so forth. So these are the halogens. So there are alkanes that contain halogens. So let's just take a look at some examples. So let's say we have something like this, ClH. So we have H and then we have H. Now this is 1 carbon atom. We have a chlorine. So this guy is we clearly named as a chloro. 1 carbon is a mate, so it's a chloromethane. So it's as easy as that, chloromethane. Then let's say we have, let's take a look at another example. We have something like this. H, Cl, BRO, for example. So we are going to name this compound. You can clearly see that there are halogens here, and they are all single bond. So that's why it's halogens with an alkane. Alkane have all of them are single bond. So now how are we going to name? In this case, we can name either ways. Either ways will satisfy our numbering. So 1, 2, let's take it as 1, 2. So we have this. So we have this as 1 and then 2. So now we have bromine, but we don't call it bromine, we call it a bromo. We have chlorine, we don't call it chlorine, we call it a chloro. We have a chloro here, we have a bromine here. Now remember, when naming your substituents, you must name them alphabetically. So bromine will come before chlorine. So we have a bromine on carbon 1, we have a bromine on carbon 2. So the name for this will be 1,2 dibromo. Now for 2 carbon atoms, it's an earth. So all single bond ethane. So this compound is a 1,2 dibromo. Oh, sorry, we missed out something. We didn't add the chlorine. So 1,2 dibromo. Now we have chlorine. 1 on carbon 1, 1 on carbon 2. So it's going to be 1,2 dibromo. 1,2 again. We have 2 chlorine, dichloro, then ethane. So it's as simple as that. So just it follows the first steps we took earlier. Identify the longest chain, which is 2 carbon atom. Identify the substituent, in this case, which are the halogens. Number them so that they take the smallest possible numbers. And then what you just do from there is that you fit them into their name. Now, if you can name this and leave the answer in the comment section. Let's say we have something like Cl, we have Cl, we have Cl, we have Cl, we have Cl. So if you are watching this video right now, I'll give you 30 seconds, attempt this question, and then leave the answer in the comment section. So do it to name this compound and then just leave the answer in the comment section. You could be surprised that you got the answer. Okay, so the 30 minutes is out. Now, if you look at this compound, you clearly see that we have a chlorine. So, if you attempted the question, please do it to watch. Now, so 30 minutes is up. So, we have a chlorine here. So, let me use a different color to spot them out. So, we have a chlorine right here. So, let me use a different color to spot it. So, this is a chlorine. So, we have chlorine on all 4 locations where an hydrogen can fill. So we have 4 chlorine, and they are just a 1 carbon atom, so there's no need to say 1, 1, 1, 1. So we can just write it as a what? 4 is a tetra, so name would be a tetra chloro, because we have 4 chlorine. 1 carbon atom is a met, and all single bond methane. So that's the answer to that question. So the name to this compound is a tetra chloromethane. So if you attempted and you got this answer, kudos to you. So let's take a look at the last 3 families in the Iupac nomenclature of organic compounds. So the next we are going to look at is what we call the amine. So for the next we are going to look at, we will just look at the amine and then the amide alongside. So the amine, outside the amine have this functional, so it is CnH2n plus 1 NH2. So this NH2 here, this NH2 is what you call the amino group. So CnH2n can be read as arrow, then NH2. So let's take a look at some of the compounds we have here. So let's say we have something like this. We have this, we have H, 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 and then we have NH2. So how do we name? So in naming this compound is simple. 2 carbon atoms. So it's going to be ethane. Then you are going to add this whole name. Sorry, the ethanamine. That's the amine. You are going to add the ethanamine. That's ethanamine. That's just how simple it is. So if we have something like this, NH2. Now you might not always see it as NH2. It is drawn like this: N, H, and H. So that's how it's drawn. So if you still also see it like this, you also identify that this NH2. So remember, I told you something earlier. 3 bonds must surround nitrogen. 1, 2, 3. So take note of that. So let's say we have something like this: CH3, H, 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 and then H. Now, how do we name this particular compound? 3 carbon atom is prop. So these are longest continuous carbon chain. So we have our longest continuous carbon chain here. But then we have a substituent, which is methyl, then number either way. So this carbon 1, carbon 2, carbon 3. So for 3 carbon atom, we are going to name it as what? As a prop. So this is going to be a prop and amine. So it's going to be a propanamine. But then methyl is on carbon 2. So for this methyl carbon 2, we are going to name it as a 2-methyl propanamine. So that's how we name amine. So we call them amine. And something unique about the amine is that they contain what we call the fishy smell. Just like we said, the esters contain what we call the fruity smell. This one they contain a fishy smell. So take note of that. So let's move to the next family, which is the amide. So let's look at the amides. So for the amides, now the amide, they have a general molecular formula. So for the amide, they have a general molecular formula of CnH2n plus 1 CONH2. So this is a general molecular formula. So what is the difference between this and the other one is this CO inside, this CO here. So that's why they also call them secondary amine. So like they're like the secondary form of the amine. And what makes them secondary? Just the CONH2. So your exam, remember CO, we call this CO the carbonyl group. We call this CO the carbonyl group. And then we call this NH2 the amino group. So you continue what we call the carbonyl and then the amine group. So how do we name? It's a very easy thing to do. So let's say we are just going to take an example and then we'll move on to a different example entirely. CO, then NH2. So H, 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 H. So this a particular family. So how do we name? That's the next thing. So so we have this. So the next thing you should spot out your functional group. So by spotting, we are going to find out this is the functional group. So this is what makes it different. In amine, we have just NH2, but here we have this CONH2. So this is clear tells that these are amides. Then our longest continuous carbon chain contains 3 carbon atoms. So 3 is a prop. So we are going to say it's a propan. Then we are going to add this entire name, propanamide. So the name of this compound is clearly a propanamide. I hope that is clear. So we are going to take the very last homologous series we have, which is the nitrile. So let's go. So for the nitrile, the nitrile has this form ROCN. Remember, RO is the methyl, then CN is called the cyano group. So let's take this off. So nitrile contains what we call the RO. Remember, RO is the alkyne. Then the CN is what we call cyano group. So just know how this is from. This is carbon, triple bond to nitrogen, then a bond connected to something else. So let's just take an example. So we have C, triple bond N, then we have an H here, we have an H here, we have an H here. So somebody might be wondering, why is this empty? Remember, 4 bonds always surround carbon. So we have 1, 2, 3, 4. So now how do we name it? Simple. Identify the longest continuous carbon chain. So the longest is this carbon. So 2 carbon is an 8. So we are going to name it as an 8, but we are going to add something special, which is ano. Then you are going to add this family name, nitrile. So it's called an ethanol nitrile. If it's stereo, you can call it a propano nitrile. So that is how we name the nitrile family. So scholars, if you have any question, any comment or any suggestion, please try to leave them in the comment section of this video. It could possibly be that you watch the video to the end after the live session. Also try to leave your answer in the comment section, as I will respond to any questions as soon as possible. And if you are watching this video for the very first time, or you have been following this video and you have not subscribed to this channel, please try to click on the subscription button and also click on the notification bell so that whenever I release any video, you always get notified. I'm sure you don't want to miss out on this video. And also you can share this video lesson to your friends so that we can all learn together. Possibly they are writing the SSCE, the UTME, GC, GCSE, IGCSE, nursing examples, UTME, or any related exam. Please do it to share this video lesson to them so that they can also benefit from this knowledge. So till you get to see my next video, do have a wonderful time. See you all when I see you in my next class.